Hello friends, myself R.D. Mahajan presenting my video on inverse Laplace transform revision part 1. There are different types to find the inverse Laplace transform. The first one is technique. There are three different cases. First case, when factors are real and different. Example, find inverse Laplace of s minus 2 divided by s into s plus 2. Here the degree of numerator is 1, degree of denominator is 2. 1 is less than 2 means it is a proper fraction. And as it is proper fraction, we can apply partial fraction technique. There are two factors, s and s plus 2. Both are real and different. And therefore, given f bar of s minus 2 upon s into s plus 2, we can rewrite as a upon first factor and b upon second factor, and it is equals to s minus 2 upon s into s plus 2. Then we try to find the value of a as, neglecting the s, we get s minus 2 divided by s plus 2 at s is equals to 0, equating this term to 0, we get, put s is equals to 0 here, we get minus 2 upon 0 plus 2, that is 2, minus 2 upon 2, we get that value as minus 1. The value of a as minus 1. Then value of b as, this time we have to neglect this s plus 2 from this. The remaining terms are s minus 2 divided by s at s is equals to, equating this s plus 2 equal to 0, we get s is equals to minus 2, and therefore substituting that s as minus 2, this minus 2 we get minus 4 divided by minus 2, minus minus it becomes plus, 4 by 2 we get that value as 2. If we call this as equation 1, substituting that values in equation 1 becomes s minus 2 divided by s into s plus 2 is equals to a, the value of a is minus 1 divided by s, b is 2 divided by s plus 2. Then taking inverse Laplace on both sides, therefore inverse of left hand side means the inverse of right hand side. Individual inverse of this term, I will write down the first positive term, therefore it is 2 times inverse Laplace of 1 upon s plus 2 and minus inverse Laplace of 1 by s. Then using standard result of inverse Laplace transform, inverse of 1 upon s plus a is e raised to minus at. Here it is e raised to minus a is 2, therefore it becomes minus 2t, and minus inverse of 1 by s is 1, and inverse of f bar of s is f of t. Therefore f of t is equal to, we get 2 e raised to minus 2t minus 1 as an answer, or required inverse Laplace transform. Second type, when factors are real and repeated, then how to obtain the inverse Laplace transform? For that, find inverse of 4s plus 5 divided by s minus 1 whole square bracket square into s plus 2. Degree of numerator term is 1, degree of denominator term is 2 plus 1, that is 3. 1 less than 3 means it is proper fraction, and as it is proper fraction we can use partial fraction technique. If you see the factors in the denominator or the terms in the denominator, the first term is repeated, second one is non-repeated. Therefore, it is a combination of that two cases, real, distinct, real, repeated, and therefore that given function f bar of s whose inverse Laplace transform we have to obtain is 4s plus 5 whole divided by s minus 1 whole square into s plus 2. And this we can rewrite as a way to write down partial fraction for such type of case. This is repeated, therefore a upon that factor s minus 1 plus b upon, as it is repeated twice, we increase the power by 1, therefore s minus 1 whole square. If it is repeated third time, it is c upon s minus 1 cube, like this. For every repetition, we have to increase power by 1. And then for this non-repeated, it is c upon s plus 2, and that is equals to 4s plus 5 divided by s minus 1 whole square into s plus 2. Then taking the LCM of this three term, LCM becomes s minus 1 whole square into s plus 2. Therefore, dividing by this s minus 1 to this term, remaining terms are s minus 1 into s plus 2, multiply by that to a, and therefore we get 4s plus 5 is equal to a multiplied by s minus 1 into s plus 2 plus b into, divide by this term to this get cancelled, remaining is s plus 2, multiply by that s plus 2 to b, we get b into s plus 2 plus c into, divide by this s plus 2 to this, s plus 2 get cancelled, remaining is s minus 1 whole square, multiply by that to c, we get c into s minus 1 whole square. Then rewrite it by taking actual multiplication, we get a into s, we get s square, plus 2s minus s, it is s only, and minus 1 into plus 2, we get that product as minus 2, plus b into s plus 2 and c into, expanding that bracket by a minus b whole square formula, it is a square means s square, minus 2ab means minus 2s, and plus b square means plus 1. And then collecting this terms of s square in one bracket, terms of s in second, and the constant term in the third. Therefore, a into s square, therefore a, no term of s square, c into s square plus c, and common is s square. From that two term, I am taking s square common. Then collecting the terms of s, we get a into s means a, then b into s b plus b, and c into minus 2s, therefore minus 2c into s, and plus constant term minus 2a, then 2b, and plus c. Then comparing these two sides, comparing the coefficient of s square with the coefficient of s square, here the coefficient is a plus c, and no term of s square means that we have to equate it to 0. Second, a plus b minus 2c is equal to, coefficient of s is here 4, then the constant term minus 2a plus 2b plus c, and here the constant term is 5. And therefore, comparing two sides, we get these three equations: a plus c equals to 0, a plus b minus 2c is equals to 4, and minus 2a plus 2b plus c equals to 5. From this we get, this implies a is equal to minus b. Put that value of a as minus b here, we get, a as minus c. Substitute a as minus c here, we get minus c plus b minus 2c is equals to 4. That is nothing but b minus c minus 2c, we get minus 3c is equals to 4. And from this we get, substituting a as minus c here, we get 2c plus c and plus 2b is equals to 5. We get 2b, 2c plus c, we get 3c, and that is equals to 5. Then adding these two equations, plus 3c minus 3c get cancelled, we get, therefore by adding these two equations, 2b plus b, we get 3b, as 5 plus 4, 9, and therefore b is equals to 9 by 3, we get that value as 3. Substitute that value in any one of the equation. Therefore, I am substituting that value here in this equation. Therefore, we get that 3c as b, transferring this to other side, we get minus 4. The value of b is 3. 3 minus 4, we get that value as minus 1. And therefore, c is equals to minus 1 by 3. And if c is minus 1 by 3, we get the value of a as minus of that. Therefore, a we get as 1 by 3. Therefore, substitute this a, b, c in equation number, suppose we call this as equation 1. Substituting values of a, b and c in equation 1. Equation 1 on left hand side is 4s plus 5 whole divided by s minus 1 whole square into s plus 2 is equal to, the value of a is 1 by divided by s minus 1. Value of b is 3 divided by s minus 1 whole square, and value of c is minus 1 by 3 divided by s plus 2. After substituting the values, we have to take inverse on both sides. Therefore, inverse of left hand side means inverse of right hand side term, and then individual inverse of right hand side term, we get this is equal to a constant term we have to take outside the inverse Laplace transform operator. Therefore, 1 by 3 inverse Laplace of 1 upon s minus 1, then 3 times inverse Laplace of 1 upon s minus 1 whole square, and minus 1 by 3 inverse Laplace of 1 upon s plus 2. And then applying standard results of inverse Laplace transform. Inverse of 1 upon s minus a is e raised to at. It becomes, here it is f of t on left hand side. 1 by 3 inverse of this is e raised to at. A is a 1, therefore it is e raised to t. S replaced by s minus 1, and it is a bracket square, therefore it becomes a problem of shifting theorem. Therefore, as s replaced by s minus 1, it is 3 e raised to t into inverse of remaining term. Remaining term is neglecting that minus 1 term, we get 1 by s square, and minus 1 by 3 inverse of this s plus a, again e raised to minus at, e raised to minus 2t. we get this is equals to 1 by 3 e raised to t, 3 e raised to t, inverse of 1 by s square is t, standard result, minus 1 by 3 inverse, already I have obtained e raised to minus 2t. Therefore, this is the required answer or required inverse Laplace transform. Case number 3, when factors are quadratic. Example, find inverse of 1 upon s minus 1 into s square plus 1. Here the degree of numerator term is 0 and degree of denominator term is 2 plus 1, that is 3. 1 less than 3 means it is a proper fraction. And as it is proper fraction, we can apply partial fraction technique. First factor is a real and distinct or different. And the second factor, if you observe, it is a quadratic equation, a quadratic factor. And therefore, how to obtain partial fraction technique, I will explain with the help of this example. Therefore, given f bar of s is 1 upon s minus 1 into s square plus 1. This we can rewrite as, for first it is a upon first factor, and for whenever we have quadratic factor, a way to write down that partial fraction is bs plus some constant c and whole divided by s square plus 1, and that is 1 upon s minus 1 into s square plus 1. We call this equation 1. And again the LCM is this product s minus 1 into s square plus 1. Divide by this, s minus 1 get cancelled, remaining is s square plus 1. Multiply by that to a, we get 1 is equal to a into s square plus 1 plus bs plus c. Dividing by this, s square plus 1 get cancelled, remaining term is s minus 1. Multiply by that, we get bs plus c into s minus 1. Simplify it, we have a into s square plus a bs square minus bs plus cs and minus c. Then collecting the terms of s square in one bracket, there are two terms, therefore a plus b into s square. Then collect the terms of s, here we have c minus b into s plus constant term. Constant terms are 1 and this 2. Therefore, it is a minus c. And that is equals to 1. Comparing these two sides, comparing the coefficient of s square with the coefficient of s square, it is a plus b. Here no term of s square means it is equals to 0. C minus b, again no term of s, therefore equated to 0. Constant term a minus c, here the constant term is 1. Adding this to equation, minus b plus b get cancelled, we get the addition as a plus c is equals to 0, and the second equation is a minus c equals to 1. Again adding this to, plus c minus c get cancelled, a plus a we get 2a, addition of 0 plus 1 is 1, and therefore we get the value of a as 1 by 2. Substitute that value of a as 1 by 2 here, we get, therefore b is equals to minus a, means minus of 1 by 2, and c is equals to b is here minus 1 by 2. Therefore, a is 1 by 2, b is minus 1. Substituting these three values here in equation 1 becomes, taking inverse on both sides, we get therefore inverse of left hand side as 1 upon s minus 1 into s square plus 1. Inverse of right hand side term, individual inverse, therefore 1 by 2 outside, inverse Laplace of 1 upon s minus 1. Minus 1 by 2 we can take outside. Inverse of taking separate division, therefore it is inverse of s upon s square plus 1 and plus inverse Laplace of 1 upon s square plus 1. And then applying standard results of inverse Laplace transform, we get inverse of this nothing but f of t 1 by 2. 1 upon s minus a, its inverse is e raised to at. A is here 1, therefore it becomes e raised to 1 times t, that is e raised to t, minus 1 by 2 times s upon s square plus 1, its inverse is cos of t plus inverse of 1 upon s square plus 1 is 1 by a is here 1 by 1 we get 1, and into sine of at, sine of t, a is 1 here. As a required answer. After knowing that partial fraction technique, the second important technique is convolution method or convolution technique. Its statement is like this: if inverse of f bar of s is f of t, inverse of g bar of s as g of t, known or we can obtain it, then inverse Laplace transform of product of that two function f bar of s into g bar of s is given by integral from 0 to t or integration from 0 to t of f of u into g of t minus u with respect to u. Then how to obtain inverse by convolution? For that, solve. Find inverse of s upon s raised to 4 plus 2s square plus 1 by convolution. Here the term in denominator is s raised to 4 plus 2s square plus 1. We can rewrite that s upon s raised to 4 plus 2s square plus 1 as it is a perfect square of s square plus 1 whole square. If expanded by a plus b whole square, s square raised to 2 we get s raised to 4, 2 times ab we get 2s square, and plus 1 square we get 1. And then as we have to obtain the inverse by convolution, we write in the form of a product of two functions. Therefore s upon, we take as first term s square plus 1. This we split that s square plus 1 as s square plus 1 into s square plus 1 and into 1 upon s square plus 1. Therefore I have converted this function as a product of two functions of s, and then we know that inverse of the first term, that is s upon s square plus 1, as cos t, and the second result inverse of 1 upon s square plus 1, it is 1 by a sin at. A is here 1, therefore 1 by 1 is 1, and sine of at 1t, it is sin t. Then call any one of this as f of t and second one as g of t. This function I am calling as f of t and this as g of t. Or we can interchange that also. final answer will remain same. Then applying convolution theorem. Inverse Laplace of product of that two term s upon s square plus 1 into 1 upon s square plus 1 as applying this, replacing t by u, we get f of u, and therefore it is integration from 0 to t. F of u is sin u into g of t minus u. In this g of t, replace t by t minus u, we get that term as cos of t minus u, and its integration with respect to u. Here it is the product of two terms of sine and cos. Therefore, convert into sum by applying defactorization. Result. For that, we have to multiply it by 2 and divide by 2. Therefore, multiplying by 2 and dividing by 2, it becomes a 1 by 2 constant outside. We have the formula 2 times sin a cos b as sin a plus b plus sin of a minus b, and therefore it becomes integration from 0 to t of sin a plus b. Sin of a is here u, b is t minus u, plus sin of a minus b is u minus this. Therefore, when you multiply by minus sign, this becomes minus t and plus u. And then its integration with respect to u. Then simplifying it, we get 1 by 2 times integration from 0 to t sin of u get cancelled, we get sin t only, plus sin of u plus u, we get 2u and minus t. This we have to integrate with respect to u. Therefore, integrating this with respect to u, sin t is a constant term with respect to u. We have to take outside the integral sign, and integration of sin is minus. Therefore, performing that step, we get inverse of left hand side is f of t is equals to 1 by 2 times sin t we take outside as it is constant term with respect to u, and integration of du is u, limit from 0 to t. Then integration of sine is minus cos of 2u minus t whole divided by coefficient of u is here 2, therefore divided by 2, limits from 0 to t. Substituting the upper and lower limit for this two term, we get 1 by 2 times sin t. Upper limit is t, lower limit is 0, we get t minus 0, plus 1 by 2. Minus sign I will cancel by changing the limit. U is 0, therefore it becomes cos of minus t minus, when u is t, 2t minus t, we get cos t and therefore simplifying it, we get that value as 1 by 2 t sine t cos minus theta is cos theta cancel with this cos t cancel with this cos t, therefore this term becomes 0. The final answer is inverse of that given function, that is f of t, as 1 by 2 times t sine t as an answer by obtained by convolution method or theorem. Though I have taken one example for each type, on the same line, on the same basis, on the same steps, you can solve any type of example. Remember the technique, how we can apply this, either inverse by partial fraction method, 3 different techniques, and convolution method when it is expressed as a product of 2 functions of s. How we can apply this find inverse of s plus 1 whole divided by s square plus s plus 1. First we check, can we apply that partial fraction technique, means can we make the real factors of this. S square plus s plus 1, we are not able to obtain real factors of it, and as we are not able to apply that partial fraction technique, factors are not possible, that, and second, it is not possible to express as a product of 2 functions of s, f bar of s into g bar of s. We have to think some other technique. Then this term s square plus s plus 1, we try to convert as a perfect square. For that we consider first 2 terms and we apply the formula. Last term is equals to middle term square divided by 4 into first term. Here the middle term is s, therefore square of it. 4 into first term, s square, we get s square get cancelled, we get 1 by 4. Therefore add this 1 by 4 and subtract 1 by 4, we get, therefore I will rewrite that s square plus s plus 1 as s square plus s. I will add this 1 by 4 and simultaneously subtract that 1 by 4. Therefore value does not change, only form I am changing, plus 1. Then if you consider first term, it is perfect square of s plus 1 by 2 whole square. If you expand it by a plus b whole square, s square, 2 times this we get s, and b square means 1 by 2 square is 1 by 4, and 1 minus 1 by 4, we get that as 3 by 4. 4 minus 1, we get 3 by 4. This we can rewrite as s plus 1 by 2 whole square. Express this 3 by 4 in the form of a square. Therefore it is root 3 by 2 whole square. And therefore that term s plus 1 divided by s square plus s plus 1, we can rewrite as s plus 1 divided by this term, we can replace by this term. Therefore it is s plus 1 by 2 whole square plus root 3 by 2 whole square. In denominator s is replaced by s plus 1 by 2. Therefore everywhere that must be replaced by same term, so that we can apply a shifting theorem. And therefore this 1 by 2, 1 we can 1 by 2 plus 1 by 2 we get 1. And then taking separate division, this s plus 1 by 2 divided by this and 1 by 2 divided by this, we get, therefore it is s plus 1 by 2 whole whole divided by s plus 1 by 2 whole square plus root 3 by 2 whole square, and then plus 1 by 2 1 upon s plus 1 by 2 whole square plus root 3 by 2 whole square. After separate division, we can take inverse on both sides. Inverse of left hand side means inverse of right hand side term. Therefore, taking inverse on both sides, we get inverse Laplace transform of s plus 1 divided by s square plus s plus 1, nothing but inverse of right hand side term. Therefore, inverse of, and then taking individual inverse, inverse of first term and inverse of second term, we get it is s replaced by s plus 1 by 2 everywhere. Therefore, it is a problem of shifting theorem. Therefore, applying shifting theorem, we get inverse of left hand side as f of t. It is s replaced by s plus a, therefore e raised to minus at. Here it is minus 1 by 2 times t into inverse of, neglect that 1 by 2, whatever the remaining term, inverse of that, it is s upon s square plus root 3 by 2 whole square plus 1 by 2. Here also s replaced by s plus 1 by 2. Therefore, multiplied by e raised to minus at is 1 by 2. Therefore, minus 1 by 2 times t into inverse Laplace of, neglecting this 1 by 2, remaining term is 1 upon s square plus root 3 by 2 whole square, using shifting theorem. And then applying standard result from inverse Laplace transform, we get this one e raised to minus t by 2. Inverse of s upon s square plus a square is cos of at. A is here root 3 by 2 times t plus 1 by 2 e raised to minus t by 2. Inverse of 1 upon s square plus a square is 1 by a is here 1 upon root 3 by 2. Sine of at, sine of a is here root 3 by 2 times t. And then simplifying it or rewriting it, from this two term I can take e raised to minus t by 2 common. Therefore, e raised to minus t by 2 common. Remaining terms are cos of root 3 by 2 times t plus 1 upon root 3 by 2, it becomes 2 by root 3 into 1 by 2, so that 2 get cancelled, into sine of root 3 by 2 times t. As final answer or the required inverse Laplace transform. Therefore, in this video, I have discussed 3 important techniques. This one, last one, when that partial fraction method or convolution method is not applicable, we can use standard results to find out the inverse Laplace. Then partial fraction technique, 3 different cases, and convolution method. Remaining techniques I will discuss in next part of the video. Like my video as well as share it. Similarly, subscribe to my channel to receive the notification of new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.